I have presented this before. The challenge with saving and uploading and indeed loading documents is that it's more like an iceberg. The parts that are visible that I can show and talk about are just, the tip, and most of the machinery, the interesting parts, are highly technical and behind the scenes. Having said that, I'll try to do justice to this very important part of the whole online machinery. So as a background, the saving needed to be done asynchronously. Previously, the way it was done was whenever you did the save, there was a save command in the background to generate the document on disk, and then that had to be uploaded back to storage, and that was done by basically waiting until the operation was completed and the storage returned to us with an OK result saying that yes, indeed, the file has been stored. That's very good from a functional perspective, but the user isn't happy if there is a pause in the interactivity of the document, if they can't open a dialogue or they're inputting new text and it doesn't show on the screen. Why? Because we're uploading their document. Some users are more sensitive when it comes to saving, in terms of they want to make sure that every character they entered has been saved. Others rely on autosave. So again, the experience would be vastly different. However, with asynchronous, this problem is completely fixed, and the whole process happens in the background, and the user is only aware with the end result, which is just the notification on the screen that says it's done. In terms of architecture, this is highly oversimplified, but I am always reminded that a bit of graphic helps in illustrating what's going on. What this is showing basically is that there is a very large degree of reusability internally. The way we organize things is by avoiding creating unnecessary threads, unnecessary resources from the system, and what we do is we rely on a minimum number of threads and system-wide resources to make sure that we're efficient, and also at the same time we don't grow the footprint. So saving is one of those things that leverages the existing system of the polling thread. So we tap into that, we create the socket, and we let the polling basically give us updates, and we go from there until we upload completely, or we time out, and then we have to go back and figure out what went wrong. With that, edge cases. So edge cases is where most of it's as the expression goes, 90% of the effort is done. What remains is the remaining 90%. So that's where the last 90% is typically spent. When you're dealing with the document lifecycle, in most cases things are working perfectly fine, and I would say 99% of the cases everything is working perfectly fine. It's just when you have multiple sub-ideal, let's say, conditions that meet at the same time, you get the perfect storm. Example, the user makes an edit, wants to close the document. So from their perspective, they just close the browser. So the document needs to be unloaded, but before that we need to save the last few keystrokes that they pressed. Whilst uploading, the server is either unavailable or returns an error, or has one of the very last issues that I fixed, the user's login has expired. So it's not that the server is not there, it's not that the document is in a bad state, it's not that we have a problem. The user just got so unlucky that in the last few minutes, they basically lost their login. And the only way that we can get it back is by them re-logging in or re-authenticating, but they're gone, right? As far as they're concerned, they closed their laptop and moved on, right? And now we're stuck. So that's one of those cases where what we do is we rely on the quarantine system, where we store the document locally, and we're working on improving that so that we make recovery easier, but at least we don't lose the data. And hopefully we will be able to get it back out to the user through the system admins. Other than that, well, we have a number of optimizations that we've done, and one of the key ones is specific to this unloading stage where you're done with the whole document editing, and what you want to do is you want to save, upload as fast as possible so that you can, load a new document and move on. You don't want to get stuck in an old instance, especially if somebody wants to edit the exact same document and you're working on unloading it. There are a number of issues that are related with when you did something. Quick example, the storage often needs to optimize the number of versions that are getting stored. I mean, from the user's perspective, every time they hit the save button, they're sure that they got their copy safe and in storage. But from the storage perspective, they worry about having, 50 versions every minute of every document, which doesn't really make much sense. So what we need to do is we need to help storage to figure out if a given version we are uploading has any user modifications, as opposed to the user is just, pressing Control S or whatever the shortcut is incessantly, and some do. So that's fine, right? We have a flag that tells the storage this is user modified version, so you better make sure that you create a version for it. But here is where you have these, timing sensitive activities. What happens when the user makes the modifications, hit save, before we can actually store the flag? In that case, we might lose it. So a lot of effort has been spent trying to make sure that we don't mark a version so that storage can rely on all of this. And in fact, this is also interesting. When we are unloading the document, we also have to tell storage, is this the final call that you will hear from us or not? And that's also very important, so that if they have skipped multiple versions, they will get a chance to do the final storing in storage. Finally, we had to, and we still have to, spend a lot of time making sure that there is reliability and stability, and also from a security perspective, we don't, inadvertently leak any information or have any gaps. So the way we approach the problem is by making sure that we have a solid testing suite that we always improve and run, and we also leverage other tools, including fuzzing and randomized testing. All of these things help us to cover all bases. Whenever we hear a bug report from a partner or a client, what we need to make sure is that we can reproduce that in a test, make sure that the fix passes, and defend against any regressions in the future, which can happen as the number of features increase and their combinations explode, basically beyond tractability. So with that,